So, day three. At the heart of all digital circuits is the portion of the circuits that are deal with logic. That is, they are the logic circuits. They use Boolean algebra, what we call Boolean algebra, which is a binary system of yes or no, or sort of like asking 20 questions to derive at a final result, okay, to understand what is the best answer for a given problem. Okay, so just to give you an example, what we're talking about for a system, okay, system made up of analog circuitry and digital circuitry. The analog circuitry then takes measurements of different variables to see where, at what point during the process it is, at what point are all these functions being executed properly or not. Okay, they take that, they measure that. Okay, they take the measurement analogically and then feed it to a digital, analog to digital uh, parameter and or component that will convert it to digital information. So that digital information then is taken in by the microprocessor, and the microprocessor takes that information, that data, comes up with a number of uh, different positions on where the entire system is going and so forth, and then feeds all that information, puts it in memory. Then that information stored in memory gets fed to a logic circuit or logic circuits to figure out, do we have enough information, enough processing to go on to the next step of processing. So logically, then it derives, yes, the answer, we can go forward and do the next step. Or no, we do not have, we have to continue where we are until we get there. All right. So that is the purpose of the logic circuit, to collect, to use all the data that has been taken through the analogic circuit and crunched it all in to figure out what is the best thing to do for the next step. And this gets repeated until the final is accomplished. Okay, so today we will learn what the components are that create that logic circuit. It's interesting to know also that although we use components to do a lot of the logic, today some of that logic is not done by the components, but is actually done by software. We can actually program the logic. Okay, you can do that through any one of the uh, software tools that are available. Okay, or you can use the components that we will go over today to do it electronically. All right, so we will study the different gates. They're called gates because they allow something to go forward or to stop it. Okay, so it's kind of interesting stuff, and all of these to uh, analyze what we are doing, we create sort of a matrix that tells us uh, the yes or the no, okay, and that gives we call that a truth table, all right, the truth table, what is it, true or is it false? Those are your binary conditions. If it's true, we go forward. If it's false, we stop, okay, until we reach a true result. So all kind of interesting stuff, and I hope I'll be able to send you something that some details of how we used it in an aircraft to make sure that an aircraft lands safely. I'll give you an example of that. I'll have to send that to you through regular email, though. Okay, so let's stop there and let's study all about logic arrays and logic gates.